This week, I interview Brian Kelly, head of Conger engineering at Cyber-Ark. In the news, Steam patches a security hole that leaked all the keys. Adobe ColdFusion servers are still under attack, and the outrageous cost of skipping test-driven development. Stay tuned for all that and more on this episode of Application Security Weekly.
This is a Security Weekly production. Rapid7 powers the practice of SecOps. Using shared data, analytics, and automated workflows, SecOps unites IT, DevOps, and security teams to make security an outcome of innovation. Rapid7 combines technology, expertise, and advocacy to drive vulnerability management, application security, incident detection, and log management for more than 7,000 organizations worldwide. Power up your SecOps practice with a free trial at rapid7.com/securityweekly. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW.
Welcome, everyone, to episode 39, our 40th episode of Application Security Weekly. I am, of course, your host, Keith Hoodlet. I'm excited once again to be joined by my illustrious co-host, Paul Asadorian.
Hey, thanks, Keith. It's good to be here. Wonderful episode of Application Security Weekly. Got a lot of cool stories to talk about. I'm excited as always.
Awesome. And we actually have a really great interview that we did a pre-recording of, so it's going to come after the news segment this week. That's with Brian Kelly of Conger, or Cyber-Ark Conger, actually. In this case, they were Conger before they were acquired. We actually had a really cool conversation about their new secret list technology, which I think is going to definitely interest a lot of our developer listeners, as well as even probably some of those application security folks as well.
Keith, you got to use your Boston accent to say Cyber-Ark.
Cyber-Ark. You got to get the Cyber-Ark. On the Cyber-Ark. What?
What?
So you can definitely check out more of that information at conjure.org/ASW. But in the meantime, we wanted to cover the application security news for the week of November 11th. By the way, happy Veterans Day to all of our veteran listeners as well. Thank you so much for your service.
Yes, thank you all for your service.
As well as, of course, to our industry, especially for those folks that are getting into security. So, Paul, where did you want to start? I know that the Steam basically bug that came out was especially bad, but it's pretty cool that they got this patched, and bug bounty researcher got 20 large out of this, which was pretty awesome.
Yeah, it's amazing. If you're an organization that pays attention to security and does, I'm not saying Steam is, but let's just say, for example's sake, that you are paying attention to security as best you can in the SDLC. And we did a great webcast with Signal Sciences and talked about that you can still have a glaring hole. And the result of this particular vulnerability was really impactful to the business. And it's amazing how we can still miss those vulnerabilities. And I don't know how well Steam's paying attention. I'm assuming pretty well, right? Because their business model, they should be, right? Because their business model really does depend on it. And this whole, so Keith, describe exactly how this happened, or a summarization of how it happened, I should say. Oh, Keith's on mute. You there, Keith? He's clicking stuff.
Somehow I got muted, which was very interesting. It sounded like admin muted me. Either way, so just trying to trick me up there. I see what's going on. Basically, Steam has a developer site, and the security researcher that actually found this, by the last name of Moskowski, found that basically there are API parameters and requests that could be made back to the developer site to get activation keys for selected games. And so the API provided the developers a way that they could effectively their partners could obtain license keys for titles to pass on to gamers for sales and what have you. And the bug was actually discovered during the exploration of the functionality of the web application itself. What came out was the /partner CD keys /assign keys API. If you requested that with a 0 key count, it actually returned a huge number of keys, like thousands of keys would come out of this thing. So effectively, it was kind of like a null pointer exception vulnerability, right? There was no keys, or like 0 amount of keys were being asked for, and therefore it gave out as many possible keys as it could reasonably fit inside the buffer, which is like a lot of keys.
Yeah, I'm curious what levels of fuzzing people are actually doing in their QA and security testing process. And I'm sure, like, as your number of applications goes up, as your number of lines of code go up, as your applications are more single page application, how do you actually fuzz, all of that? And if you can, I think it's pretty easy to detect this type of vulnerability. In other words, if I send you a valid request and I get a valid response back, I should get one small piece of data back, one number, right? But if I send something else, and even just based on the size of the response, if it's 20 times greater than my normal response, well, that should flag for someone to look into. My thought, right? But how do you come up with all those different? I mean, of course, we're trying in security teams, QA teams, we're trying to come up with those examples and those test cases, but of course, it's difficult.
So the interesting thing there is, and to go back to the teachings of my sensei Jason Haddix for a moment, is any input that the server will read or will receive in some way is a fuzzable input. Mm-hmm. So whether it's a cookie, whether it's an input field, whether it's an API value, such as the number of keys to be returned, as long as the server reads whatever it is you're sending to it, all of those fields are potential input vectors. And it's crazy, actually, as we get to the DJI story later on. It's the same sort of thing. It's just like, here is another input field that a lot of people don't necessarily think about because it's not in a form field on a website, right? Maybe it's in the URL bar, maybe it's in a cookie somewhere, maybe it's in a session ID token or something like that. But there are any number of inputs that are potentially able to be passed back, including, by the way, like the type of request that you're putting in, or the size of the request that you're asking to be submitted back to the server, or what version of TLS you're willing to talk to or communicate it with. All those things are fuzzable inputs potentially. So
finding those fuzzable inputs is more difficult today. I mean, right, back in the day, you had a form, and you're like, oh, well, now I know what the fuzzable inputs are. Right, today it's not as apparent.
Right. Well, especially when it comes to things like just single page applications, right? Because a lot of them, to protect them from malicious users, they actually will hide different form fields, for example, that when you submit them, it's effectively what's called a nonce, right? So it's a unique identifier for that page for that one request, which is intended to be able to prevent you from sending multiple requests to the page, because that little nonce value is unpredictable. It's supposed to be effectively entirely random, or at least cryptographically random. So in this case, though, it was literally an API parameter, right? So as long as you could continue to get a new nonce and submit a different API parameter, well, all bets are off, and especially if you get a 0 value, which is what they did in this case. The interesting thing about this is, it sounds like, based on the actual article itself, so that was written by Sean Nichols for the Register, that in the article they cite that the researcher, Moskowski, entered a random string into the request for the title to be picked at random. And that, to me, sounds like the randomization string is probably maybe just numbers, right? Because if it was numbers, letters, some subset of characters, harder to get a random title accurately on the first guess. But the researcher put in a random string for the target of the title that was being sold for the game, got 36,000 Portal 2 keys returned back to them for what would equate to, think about 36,000 times about $10 a pop for each sale of the game. Like, if they were to sell it illicitly, that's a lot of money.
Yep.
So $15,000 bounty plus a $5,000 bonus from Steam, awarded by, I think it was, early August by Valve, and then it actually went public on October 31st. So that's pretty cool and pretty great payout, I'd say. Well worth it, given the value proposition that Steam offers.
Agreed.
By the way, so we did mention just a moment ago the DJI vulnerability. Now, I know that you covered this as well on, I think it was PSW, but this particular write-up that I actually have here, so this is a write-up from Checkpoint that I link under story number 3 for bugs, breaches, and more. This goes through this kind of piece by piece in just such a beautiful fashion. If you are looking to get into anything from, hey, how do I actually do like this whole security research bug bounty thing, or even how do I get into mobile application security, this write-up is just incredible, right? From the very beginning, basically what they talk about is they were doing some research into the DJI accounts themselves to see, okay, is there anything that we can do from like authentication bypass or like, you know, some sort of account takeover? What they found was there was some interesting information that was available from, say, like how to access some of the different account parameters, specifically on the DJI forum of all places. So what they were looking for first was an attack that would allow them to effectively bypass content security policy and any sort of other protections that the web server was offering. And so what they did is they actually went through and found a specific cookie, in this case, that was associated with the user account. So it was kind of like a session ID cookie, for lack of a better term. But that session ID could be then used by a potential attacker to take over the account on basically across their platform, right? So any of their web presence platforms, it could be used for forum.dji, account.dji, and store.dji.com.
That's crazy though. So the same ID and login cookie is your credentials essentially for the web forum, also the one that if you use a mobile app, the backend that it's talking to, and what do they call it? The drone flight console.
Yes.
So it's like everything to do with DJI, that one set of credentials is valid for. And you would think that there would be some separation such that when you pull credentials and authenticate to one service, that it's not directly transferable to the other, that there's some re-authentication that's happening. At least if your IP address changes, right? I mean, I could see from the same IP, but even that.
The argument would be, I would imagine, so there's two things, Paul. First is they're using a very DevOps process, right? Like, why write 3 different authentication mechanisms when you can write one?
Right.
Like that's one kind of thing. The other side of it is this, right? Is they're thinking about this as, hey, I want a seamless customer experience. So
agreed. It is, and from a user perspective, it is kind of annoying. Most of us have probably been in that situation where I'm logged into the product, and then there's a separate login for the support portal, and that's actually quite often that's the scenario, that the forum or support portal, right, has that set, and you're mad because you got to track both of them. So DJI is like, well, let's just make it seamless and have it applicable everywhere.
Right. And that was a big mistake in this case because ironically, they did cite that it was using the OAuth framework to actually do the kind of authentication process. But what they started with is they looked at ways in which they could basically extract this key from other users. And the scenario that they came up with in this case was that they would need to find a subdomain that was unprotected by an HTTP only attribute. So it would allow for JavaScript to leak the cookie. What they found was in forum.dji.com, on one of the GET requests, there is an action called down remote image. And what they could actually do is, because the quote unquote add slashes function, which would do effectively a kind of like escape characters for, single quotes, for example, double quotes, or even like a forward slash, they just did the very, the age old trick of adding a backslash, or excuse me, a
forward slash, extra forward slash. Yep.
Before the single quote. And then they would effectively be able to kind of escape out of the context. And so what they ended up doing is they would create what was a comment to comment out the rest of the parent update down image list for that function. and then they basically rewrote the function to send that cookie off to their own website because the forum itself wasn't protected with HTTP only requesting. So now it's like, okay, I can now send anybody that clicks on this link their cookie to this off website, non DJI owned, perhaps malicious actor owned website via cross-site scripting, which was like just the beginning, right? Because then they went layers and layers deeper. They actually ended up going through the DJI app itself. So they have a desktop app as well as a mobile application for this. They talk through how they bypassed certificate pinning on the actual mobile application, which is another very cool deep dive into some of the mobile side as well, using a tool called Frida. And then what they end up showing is they kind of like screenshots throughout the process of like Burp Suite Pro and intercepting traffic. And then they found in the mobile application is there was a similar token. There's like a cookie key and a token. But one of the things that was interesting is the cookie key was the same meta key or the MCK cookie that was from the DJI forum that allowed for authentication into other things. And then the token parameter was where they could get basically from the request mobile.php to start like trying to grab cookies or get a cookie. So from there, basically the attacker needs a meta key and a token to replace with their own. So through the cross-site scripting attack, then they would enter their credentials and log in and just replace the cookie. And they now had full access to the victim's account on the application. So that would give them a ton of access. And I mean, like looking at some of the photos here as well, you would get, let's see, I'm just going to go to the notes that
So it sounds like he said it wasn't just like one vulnerability, as I was simplifying it before, because SSL it should protect you at some level too, right? So there was multiple kinds of issues they had to overcome to pull this attack off, as is usually the case, right?
Well, SSL actually isn't going to protect you here. So the problem is that SSL will encrypt your traffic from this being sniffed by anyone that's in the route from or to your computer to the server. It just makes sure that the traffic is actually encrypted. Now, the clicking on the link that would then send your cookie off to this malicious website.
Right. SSL doesn't help you there.
It could still be encrypted, but by the way, it's encrypted between the server that DJI owns and my server, but it doesn't mean that the data is encrypted when I receive it. It just means that the traffic is encrypted so no one else can read it.
They can just create a new session via SSL to the backend mobile app, but you said there was some kind of certificate pinning that they had to overcome.
Yeah, so basically what it was here, and they kind of go into this a little bit, was that they were looking at some of the processes themselves specifically to try and decompile or disassemble SSL pinning mechanisms to kind of keep you from basically the SSL pinning mechanism here is what Burp Suite Pro does is it has a certificate that allows you to kind of man in the middle all the traffic, but SSL pinning on the mobile application prevents you or is supposed to prevent you from getting kind of that man in the middle from the traffic on the mobile application.
Gotcha.
So that's what they ended up having to bypass so that they could actually read the traffic process to see where they needed to then insert the malicious cookie and then see what they could get from it. So what they did is after they made... I'm sorry, what?
I love the write-up. It's great.
Yeah, it's just, it's beautiful. I mean, they talk through the entire process, the problem space that they encountered. Like most write-ups will be like, hey, I did this really cool thing.
Yeah.
I did I waved my magic wand and suddenly I've got, reverse shell. But this one actually talks about like some of the struggles that they had, right? Like the struggles that they had with getting the debugging tool Frida to actually connect to the mobile application in the appropriate way. What seemed to be like a bug in the actual way the application was being called, which had a race condition, which allowed them to get man in the middle in a debugging mode and then change over the certificate pinning to the X509 certificate that they needed from Burp Suite Pro. Basically, it was a Burp Suite Pro certificate casted as X509, and then loading that into the key store and all the way down, right? So they go through this just top to bottom and just what I think is probably the best write-up I've seen all year. This is from a pure attacker perspective and a way to really learn how some of this stuff is done, including the tool set. This write-up from Checkpoint is just, it's on the money.
We should have an award ceremony at the end of the year. Best write-up. Kind of like the Pony Awards,
totally.
Right?
Yes, you call them the Paul Awards, though.
Yeah, the Security Weekly Awards. I think is where I was going with that, right?
SWA, SWA, the SWAs.
That's it.
The sound a helicopter makes as well. Swah, swah, swah. Anyway, this was a very good write-up. It's Bugs, Breaches, and More #3. So just go to wikis.securityweekly.com. It's ASW episode 39. It's just far and away the best write-up I've seen all year. So I think people will enjoy that. The other interesting article, though, Paul, that I wanted to jump to is that in this case, Adobe ColdFusion servers are under attack. It's 2018, right, Paul? Like we're supposed to be beyond this now.
I'm curious to see what the adoption is still today of ColdFusion and what some of the use cases are. I'd imagine, my guess, and I could be wrong, and listeners will correct us if we are, I hope. If history tells us they will. So, like, who's using ColdFusion? And I'd imagine, my guess is it's embedded in some kind of other application and or, as us old people call it, like appliance, right? Like it's under the covers somewhere being used, and not necessarily something that you're like, oh, we're going to create a new project and the web framework and platform we're going to use is Adobe ColdFusion. I mean, maybe, but I'm just not sure what the use cases are today for that.
You know where it is surprisingly used a lot is if you go to some very large corporations and you go to their investor page, when you use a tool like Wappalizer or BuiltWith, one of the things that pops up right away is ColdFusion. And almost all of the applications that I've seen that are investor type or investor relations type pages are using ColdFusion.
There must be a software company, right, that produces an application in ColdFusion that has a specific use case for the investor page. That makes sense for where we'd see it today. So
honestly, I don't know like if there's money more than that, but that is the case that I've always seen whenever I've done kind of bug bounty hunting on very large scope programs. Is I just go and I start looking at what sort of software stacks am I looking at? The one that always pops out, and I'm like, ColdFusion, that's not cool. Is investor pages 9 times out of 10.
And I mean, it's got to be used in a bunch of places because we do see new CVEs being issued, security research for this particular product, and some threat intelligence on it as well. So obviously, there's a reason why attackers are going after it. Probably, for sure, largely because of the use case you presented.
Right. And in this article, it's a ZDNet article by Catalin Campagnu, is actually, so it's if you build it, they will come #2, is nation states are actually using attacks against Adobe ColdFusion now as well. So what was interesting in this article is Adobe, in their kind of latest big update on September 11th, effectively they patched a bug that they reintroduced that had already been patched previously. Which is super interesting to me because the CVE itself for this was CVE 2018-15961. What it stemmed from was Adobe has replaced the technology inside of the native ColdFusion kind of like WYSIWYG editor, which was originally FCK editor to CK editor. Now, what's kind of interesting about this, and this is like a 9-year-old change, is when they made the switch is when they actually introduced the unauthenticated file upload vulnerability that was originally patched in FCK editor's ColdFusion integration back in 2009, right? So it's like, hey, we're going to change over kind of this internal functionality of the application that was already patched for the vulnerability that was introduced, and it ends up reintroducing a vulnerability. I mean, it's just crazy.
We were talking about stuff like this too, now that we've seen fixes to vulnerabilities and malware, have that almost 20-year lifespan. And as it has so much time that you can develop, either you're developing defensive code to look for something, or you're trying to patch something over, the lifespan of 10 plus years, you tend to reintroduce vulnerabilities. And on the defensive side, I'm told through some security researchers that a lot of products today won't detect like really old, not even malware, but attack tools, like some of the original, like maybe password dumping or whatever your tool set is, that they're not detecting those today because their products have changed and new techniques have come out. And somewhere in that process, and we've seen this in our 14-year history here at Security Weekly Covering, we've seen this, right? You get to a certain point, and all of a sudden, by fixing something, you break some older thing that either you were trying to detect, or as in the case with ColdFusion, you've now reintroduced a vulnerability or exposed a new vulnerability. There was a variation on the old one, because maintaining security from a feature set that spans multiple years and you've done multiple fixes. I mean, like if you've done any kind of software or programming, it's probably pretty easy to say, oh, well, this protects the new thing, and not go back and do your regression testing to test the old thing. It really comes down to regression testing is really what it comes down to.
Effectively, and what that means is malicious unit tests, right? You need to write malicious unit tests for things that you're very specifically patching to make sure that it doesn't actually reintroduce the vulnerability later. It's the same reason that you have unit tests for other bugs that you're fixing, right? It's the same problem space. What was interesting about this is it effectively came down to a file upload blacklist, which, by the way, usually you want a whitelist policy. So I thought that this was kind of interesting that they're still using kind of a blacklist here. But it allowed users to upload Java server page files or JSP files on ColdFusion servers. And since ColdFusion can natively execute JSP files, effectively you've got remote code execution, for lack of a better term, right? Because you upload the file and ColdFusion can call it, so you just call it via the browser, and bam, you've got access to the system now. You pretty much own it. So what was interesting is they actually cite there is at least in the article, there was a APT group that was basically putting JSP versions of what's called the China Chopper backdoor to effectively take over or allow for backdoor access to those servers at a later point in time. The other interesting thing, though, was that the original researchers at Velexity identified this case over the summer as well, where some Indonesian hacktivists had been defacing websites that were hosted on ColdFusion servers, apparently using the same vulnerability. So it sounds like perhaps then Adobe actually ended up patching this because it was being used in the wild, not knowing that they had actually reintroduced this vulnerability until well after it had been exploited in the wild.
Well, I think, not to jump around too much, but I think that really highlights your story number one under food for thought, the outrageous cost of skipping test-driven development and code reviews.
Yeah.
I mean, all the bugs we've talked about, essentially, we could tie them back to making sure that you're doing either agile, some form of agile or test-driven development, right?
For sure. And this is actually, it's a little bit of an older article by Eric Elliott back in 2016, but it's kind of resurfaced lately, and especially because there's been a lot of talk about test-driven development, or TCR as well, which is test and commit or revert, which is kind of another pattern that's starting to take shape in the development world. But what it actually showed was, for those who manage software products, they've found that test-driven development can reduce production bug density by anywhere from 40 to 80%, right? Like the density of the number of bugs that you have in your production quality application gets reduced significantly. And IBM System Sciences Institute also found that fixing a production bug costs something like 100 times more than fixing the bug during design, and 15 times more than fixing the bug when it's actually in the process of being implemented. Which, in my mind, it's interesting because they actually give some charts and some breakdowns as well of kind of like what this really counts as. And they talk about a fictional application that takes about 1,000 hours of upfront implementation with or without test-driven development, using just kind of that middle number of a 60% density of bugs and kind of man hours of time saved. So basically, from the process, they say, hey, look, if we did test-driven development, we've saved 623 man hours for a team of 4 for about a month of development time. So at $95K average US salary at the time for developers, plus bonuses, that's something like $37,000 saved to the company for just a month, right? So you multiply that over the course of a year, and you're well over 400K saved to the company for that one project alone, especially if it's continuing to develop at that pace.
And it's interesting, our stories kind of allude to bugs that get fixed and then need to be fixed again, which just kind of outlines the horrors that are pointed out in the story, right? I mean, it cost you money the first time. Now it's going to cost you money again to go back and fix it. So not just trying to fix it the first time, but spending even a little more time to make sure that it's fixed for good moving forward into the future, making sure your processes are in alignment with that, is super important because no one likes to have to fix a bug more than once. I mean, we all know as developers that are listening, right? You get in there and you fix a bug, you feel good. I fixed something, it's great. When it comes back around and you're like, crap, I didn't fix it right the first time, you're like, oh, God, like it's a really frustrating thing to deal with and a costly thing for your company and your development lifecycle. Now you're just spending more time fixing bugs and not implementing new features.
Yeah, yeah. And talking about new features for a moment, one of the things toward the bottom of the article that they actually talk about is the cost of interruptions, which I think is something that it gets dramatically overlooked
Yeah.
inside of our industry, which is simply put, it's for every context switch that you're doing from a development perspective, it can cost something like 20 minutes of of developer productivity to actually go ahead and get kind of back into your groove, right? So that's 1/3 of an hour for every context switch. You context switch 3 times in a day, that's 1 hour of development time lost right there. So for that, it's like, okay, your feature development, then your bug fix, and then your bug fix doesn't work. So you're going back and trying to bug fix again. And then you're going back to feature development, but maybe it doesn't work again because you reintroduce the bug, and now you're back at fixing it. And so this is a situation that just it's a very negative kind of spiral, right?
Mm-hmm.
Where unless you're doing test-driven development and you're keeping your developers focused on driving forward, you're going to have a lot of bugs. The other interesting thing that they actually cite here is, according to Microsoft research, an interrupted task takes about twice as long to complete and contains about twice as many errors as an uninterrupted task. So you're going back and context switching to fix a bug, and now you're introducing more bugs, probably twice as many bugs.
Right.
Which is just like, oh my goodness. So it can get out of hand really quickly, which is kind of funny because with Food for Thought number 3, our commit strip comic of the week, talks about the experience is a candle. And perhaps a bit of test-driven development would have saved our heroes in this story. So I think our listeners will enjoy that. With that, we are going to go and take a short break and then come back for an interview with Brian Kelly of Cyber-Ark Conger Engineering. In the meantime, I hope everyone remembers to get, commit, and stay classy, and stay tuned for that interview because I think you're going to want to hear about Conger's new secretless technology.